Hello again, everyone. We're going to go ahead and take a look at another problem from our test today. We're going to take a look at target number 6. So we have the graph of the cubic polynomial p of x intersects the x-axis exactly twice at 2 points a and b, such that ab is 6. Given that p of 1 is 32 and the leading coefficient of p of x is 1, compute the largest possible value of the y-intercept of p of x. Now, a cubic polynomial, right, if we assume that it has no repeat roots, right, then it will always cross the x-axis either one time or 3 times, right? But here we can see that that is not the case. We only have 2 x-intercepts, so we'll call that we'll say x1 comma 0 and x2 comma 0, which means that one of these has to be a repeat root. Otherwise, we wouldn't have an even number, of x-intercepts for a cubic polynomial. Now, looking at that, let's say that our first root, our smaller root without loss of generality, is going to be r. So we'll have r comma 0, and our larger root will be 6 more than that, since we have a distance of 6 along the x-axis, so r plus 6 comma 0. Now, that means that our equation p of x can take 2 possible forms. P of x, right, can be of the form x minus r squared times x minus r minus 6, or we can have p of x be x minus r times x minus r minus 6 quantity squared, depending on which root is repeated. At this point, we can plug in p of 1 equals 32 to get 32 equals, in our first case, 1 minus r quantity squared times 1 minus r minus 6. And then in our second one, 32 is equal to 1 minus r times, and then I'll combine them here, negative 5 minus r quantity squared. So if we look at our 2 equations here, we can see that the case on the right, we have 2 integer solutions. We can either have r is equal to negative 1, which will give us 2 times 4 squared equals 32, or r equals negative 7, which would give us 8 times 2 squared is 32. So both of those work. Now, these two would give us the functions. Assume things in the way. We'll either get p of x, right, is equal to x plus 1 times, and then that would be x minus 5 squared, or p of x is equal to x plus 7 times x plus 7 plus 1 squared. All right, so now looking at that, right, we can either get, and remember, to find our y-intercept, we plug in x equals 0. So we'll either get 0 comma 25 or 0 comma 49. And of these two, that would just be 7, wouldn't it? Sorry about that. So we can have 25 or 7 here. All right, cool. Now take a look at our second equation, right? So we have now the double root being the smaller of the 2 roots. We can find relatively easily that this has no integer solutions. However, right, we can try to bound it and try to bound our roots. How? Well, we know that the general shape of a cubic will look something like this-ish. And we don't know where exactly these are, but what can we notice? Well, we can notice that if 32 is equal to 1 minus r quantity squared, right, times, this is negative 5 minus r, right? This part is always non-negative. This part is not, okay? So Okay, so we have r equals 1, and then our other solution is the one that's harder to find, right? Is this one. So we'll know r equals 1. We'll come back to r equals 1. Now, if we look at this here, right, we can kind of bound the solution based off where it's positive and negative. Now, this term, right, as we mentioned, can simplify to -5 minus r. So if r is less than -5, then it's positive, right? And sorry, I solved it as if this whole thing was equaling 0. So ignore the r equals 1 thing that I just mentioned. However, this first term is always non-negative. And the second term, we can see that if r is less than -5, then the right-hand side is positive. And if r is greater than -5, then we end up getting a negative number. And that's not fun, right? But how does that help us? Well, that means that we know that the root is going to be between -5 and -6. Because if we plug in -6, right, then we will have a positive number. Now, notably, if we plug in -6 for this, then the right-hand side will evaluate to 49, right? So for p of x, -5 is an x-intercept. But when do we get 32? That happens between when r equals -5 and r equals -6. Why is that the case? Because when r equals -6, the right-hand side evaluates to 45, which is too high. And when r is equal to -5, it's 0. So we're between -5 and -6. So that means that r, right, is between -5 and -6, which means that our second value, our second root for p of x, which is r plus 6, is going to be between 0 and 1. Now, why is this important? Because if we evaluate this, right, x minus r times x minus r minus 6 at x equals 0, right, then that will give us a negative answer, which is definitely not going to be the largest possible value of the y-intercept of p of x. So therefore, we have from our first case our answer, which is going to be 25.
Hey, this is Tim. Hope you're enjoying our videos. If so, you know what to do: like, subscribe, turn on notifications, all that sort of thing. But what I'd really want to invite you to do is to send us an email at media@mathleague.org. Tell us which problems you'd like to see us cover next in our video series. Take care and see you in the next video.